we are in the using coding to explore algebra and geometry session. This is mainly for middle school and high school teachers. But if you're not a middle school teacher, you're more than welcome to stay and watch and learn what TI is, or what TI has to offer in terms of integrating computer science in algebra and geometry. Our guest speakers are Curtis Brown and Beth Smith. And I will just read a quick bio for Curtis. Curtis currently works as a math specialist at Texas Instruments. He taught math and AP statistics for several years, and then he joined the National Math and Math in Motion series. The National Math and Science Initiative. Sorry about that, as a statistics specialist. Since starting at TI in 2015, he has led many content development projects, including Math in Motion series. He's not a computer programmer by training. He has found a love for coding in TI Basic, particularly for the purpose of teaching mathematics in his spare time. He enjoys kayaking and fishing with his sons and spending time with his family. Beth Smith is an educational technology consultant with Texas Instruments. She strives to empower teachers and inspire students to succeed in math, science, and STEM. Prior to joining TI, Beth taught middle and high school mathematics for 25 years at Episcopal School of Jacksonville in Jacksonville, Florida. Beth has also served as a math tutor and a math forward coach and a T-Cubed national instructor for Texas Instruments. She has a bachelor's and an MBA and an EDS in curriculum and instruction from the University of Florida. Thank you both for conducting this session. I am going to turn it over to you, and I will be here to help capture questions that come in through the chat. If you need me, just give a shout out. I'm going to be here in the background, okay?
All right. Thank you, Lynn.
Thank you both.
All right. You ready to get started, Curtis?
Yeah, let's get going.
Okay. So as Lynn said, Curtis and I work for Texas Instruments, and we're here to introduce you guys to coding, or just perhaps you haven't coded on the calculator, the graphing calculator platform. And here's our information. If you ever want to get in touch with us, just our emails and also our Twitter accounts, and we'll show you the slide at the end of our presentation as well. So let's get going. So by coding, this is what we're going to talk about today. We're going to explore how to code and how to implement this into your algebra and geometry classrooms. And we're going to talk about a little bit about why coding, and give you an overview of our coding and STEM program. And then we're going to code the formula for slope and a program that'll help students understand and see what kind of triangle they're dealing with according to the angle measurements and lengths of sides. I think this is a great quote to start with. I know it's one of Curtis's favorites. It's that, why do we code? And Steve Jobs said quite a few years ago that everybody in the country should learn how to program a computer because it teaches you how to think. And when I think about why I was a teacher for 25 years and still love the education environment, is because we want our students we want their brains to grow. And we want them to become smarter and prepared for the future. And I think that this is just a great way to help our students think. So as students code, and I'm looking at the chat a little bit, we do not need any coding experience whatsoever to be here. So you guys are all in a great place. We're helping our students problem solve. We're going to help them grow through and just productive struggle at its best. Is they're going to make mistakes and they're going to have to go back and find these. And they have to be able to persevere to do that. And coding also helps with procedure fluency. So if you're at point A and you need to get to point Z, how are you going to get there? I think it also helps our students to get beyond that concrete level of thinking and reason abstraction. They may be modeling, they may be precision. For example, here's a big difference for having our robotic car that will show you the turn 30 degrees versus 40 degrees. And regardless of whether they choose to go to college or to get a technical degree or some type of career, I think that the majority of students in today's world are going to have to at least understand the thought process and the language behind coding to be able to be successful. So before we get started, Curtis, do you have anything to add to that?
No, I don't think so, Beth. I think you got it. This whole thing, why coding and why coding in math class? It's such an important thing for us to prepare students for the future, and I think this is a great way to, one, engage students and to give them a different representation. I know in math class we talk about multiple representations, looking at things from a graphical or an analytical or a verbal or some sort of physical sort of perspective. And I think adding code to that mix gives us one more expression, one more way students can interact with mathematics. And secondly, I like the quote that you put up from Steve Jobs. It teaches them to think logically. And I think this is one of the most important things. One of the biggest reasons why we do the math that we do is developing the thought process and the thinking and the ability to reason abstractly and model and attend to precision, all of those things that you've got listed here.
All right, let's get going. So in the chat window, what I've done is I'm going to send you guys a link, and you can download it now, or if you you may have an Inspire and 84 with you, but if you don't, you can certainly click on that link and perhaps maybe multitask or just watch and see what we're going to do. As we're really continue to work with you guys as educators through this whole COVID-19 program, and through the end of June, we are offering our teacher software and student software with a free 6-month subscription. That's for PC and Macs. If you need a solution to a Chromebook, just go ahead and send me an email at the end of this. So one thing that we're trying to really help teachers understand is that you can embed coding into your curriculum. So we get a lot of questions, well, how am I going to ever fit this in? And so as we go through today, I want you to really think about how can this be embedded into your curriculum and maybe replace some of what you're doing. And the whole concept is that if you can code it, then you know it. And hopefully you'll see how this can help students develop conceptual understanding, perhaps as they discover and derive formulas. And again, with our rover, imagine your students driving around Mars so that they can show you that they understand the coordinate system, or program the rover to draw a triangle and a square and a pentagon. And so they discover that the sum of the extra angles is 360 degrees. And they discover that the formula for the sum of the interior angles, rather than us just write it up on the board and have them plug in numbers. And I think that really does a nice job of helping students understand the why behind the how. And also just think of it as an alternative assessment. And you're gonna see from my experience just working with teachers and students in the classroom is a lot of times the students that quote unquote struggle in the math class, as we're doing some of these activities with them, they are the ones that end up being the most engaged and actually complete what we call our challenges first. And it's awesome because then all of a sudden they're feeling good about themselves and they're like, hey, I can do it. And on the flip side, we have those other students that tend to be those traditional type learners that want to memorize everything, and they struggle getting out of the box. But we also know to be successful in careers in life, we've got to be comfortable out of the box. So it just does a really, really nice job of just really getting all students to grow. We're going to really go over our STEM program and coding at the end of this, but What we're really going to talk about today is, let's say all you have are graphing calculators in your classroom, or all you have are student software. How can you work with just this in the classroom? And they can go through 10 minutes of code, but we're going to get this specific to what you may want to do in algebra and geometry. So with our STEM program, we have our graphing platforms, we have the Inspire, and we have the 84. And the coding that we're going to do today, you can do on any 83 or 84 graphing calculator, no matter what, whether it's the Plus or the CE. And you can also do it on our different TI Inspires. If you want to go a little bit further, we have a TI Innovator Hub. This is our microcontroller. So I want you to think about this as the brain. If you've ever heard of like Raspberry Pi or Arduino, this is TI's version of that. And that hooks up to the calculator. And so there's a lot of cool things you can do with that versus light shows, sounds. And then in addition to that, which actually there's a lot of schools and districts in Georgia that have our TI Innovator Rover, the hub goes inside the rover, and that's our robotic car. So we can program that to drive. You can put a marker in it. It's going to draw whatever it is you program. There's a motion sensor and a color sensor and a lot of other things there. So Curtis, do you have anything to add right now before we go forward?
I think so. I mean, you covered all of the stuff that we've offered. Maybe one thing, and that is especially for our CS folks out here that are getting so much other stuff going on. This fall, this winter, we'll actually be rolling out an operating system for our Inspires. It's going to include Python. So we're going to be adding the programming language of Python to the TI Inspire platform, the TI Inspire CX2 platform. I should be very specific about that. It'll be the CX2s that'll have that Python added to it. But yeah, just adding another language. We're going to be using TI Basic in this session, but be adding Python in the fall, which will be exciting. I'm super excited about that.
Awesome. So before we get started, as Curtis mentioned, this is TI Basic that we're looking at, and it's menu-driven coding. And what's nice about menu-driven coding, it's great for students that have had experience with drag and drop. It's also just a great program to introduce students to coding. And you know, even if they're more advanced and they're working with things of Python, it's still just it's something that's really nice and easy that I think that all students can be successful with. And all right, so the first program we're going to write, we're going to be using the 84 plus family, and we're going to write a program for slope. And you know, basically we need to, when we're talking with slope to our students, I know that when I introduced slope with my pre-algebra students, I never really gave them the formula. We really talked about it, and we talked about looking at 2 points on a coordinate plane and drawing that line and what's going on between the two, how do you go from one to the other, and then even plotting 4 or 5 points and having them plot them, having them label them, having them do the table, so that they really understand that it really was a ratio of the vertical over the horizontal changes. And I think the sooner that we can refer to slope as a rate of change, that really helps our students as they move on mathematically and through science, so that they're not just memorizing that formula. And understanding that the slope could be positive, negative, 0, and defined, and then really introduce them. So, okay, what could a formula be if we're going to try to design or derive this formula? What would that look like? And so this is the formula that we're going to program with the 84 to get started. And so when you program your calculator, and I'm just going to pop up the 84 here. And let me resize this just a little bit so we can see both of these. Well, don't you love technology? All right, here we go. So I've got the TI Smart View. So this is the teacher software for the TI-84, and that was the link that I sent you to go ahead and get that 6-month free prescription. And if you need something after that, just please feel free to reach out to me and I can help you out. And so if we're going to write a new program, we're going to start on our home screen and we're going to press our program button. And every time I press a program, every time I press a key on here, you can see that that's highlighted in red on the keypad. And we want to basically write a new program. And before I do that, I want to go ahead and show you the slope program that I have written so that you know where we're going to go with this. So if I want to look at or edit a program, I can go ahead and arrow over to edit and press enter. And this is the program that we're going to start with, and we're going to realize as we go through this that there's a little error involved with it. But Curtis and I were actually chatting about this morning, and we talked about that productive struggle. I think this is a great way to look at this. And so this is a really simple program where basically the students would just ask for the values of their first ordered pair and the values of their second ordered pair. And then we're going to basically store whatever they put in as X1 as A, Y1 as B, and so on and so forth. And then you can see down here on one line of our command, there's your formula. So take the difference between your Y coordinates and take the difference between your X coordinates. And let's go ahead and store that value as S. And then whenever we display something, if we have something in quotes, that means that on the home screen, we're going to see the word slope and colon. All right. So Curtis, anything to add at this point?
Sorry, forgot to unmute. No, I think you've got it. One of the things that I think is good here, though, yeah, I will add something. I always say no, and then I add something anyway. So I'm just going to go ahead and add it. So one of the things I think is really, it's kind of unique, and I think several folks have made note of that quote you put up there, that if students can code it, then they know it. I love just kind of turning them loose with something like this and getting them thinking about ways that they can communicate with this device in order to compute the value that they're looking for. And so a real understanding of what slope is and what the response, what they're going to get back actually is something that's required from the students as they think about this. And so I really do believe that idea that if they can code it, then they know it. And so, yeah, I love the way that you've got this set up, and everything looks really clean and clear. Students should be able to produce this, taking some sort of an input and then displaying some kind of an output. I know you've got a couple of things here that maybe would have gone past a student, like using the input command. Also an option for prompt in TI Basic, which is gives them, I can just prompt you for A, B, C, and D. But I like the fact that you used input here because it explains to the user how this program works a little bit and what it is they're doing. So I like the way this is working. This looks cool.
All right, awesome, thank you. Okay, so if you have a software or if you have a TI-84 in front of you, we're gonna just go ahead and see how to code this. And we've got the directions right beside there. So I'm gonna go to program. Oh, I need to get to the home screen first. And I will say on the 84, once you exit your program, it's gonna automatically save that. So you don't need to worry about doing that. And so I'm gonna arrow over to new, and I have create new, so I can just press enter. And the first thing that we have to do is we have to name this. And you'll notice that hopefully you can see on your screen that there's a block there blinking with a capital A in it, which means that we're in alpha mode. And I always like to interject here. I don't know how many of you guys have been around since the good old DOS days. where we didn't even have a mouse when we first got computers. And so the type over mode was the cursor blinking as a block. The insert mode was the cursor blinking as your underline. And that just gives you an idea of how long the TI-82s and 83s and 84 models have been around. Yes. So that's just, to me, is awesome. So I'm going to name mine slope 1 just because I already have a slope, or slope A just because I already have a slope, but you are free to name it what you want. And you can see the the keys above everything are in green. And so if you want to access the third function, whereas a lot of these keys have 3 different functions, you would press the alpha key. And you can notice if we weren't in lock mode, we can press second alpha to lock that. And so as a hunt and peck for slope A, I'm just gonna, and I want to interject too, is you can't have a QWERTY keypad, because if you did, then you would not be allowed to use any of these devices on your high stakes test. So I'll just call this slope A, and then we're going to press enter. And so now let's look at how we're going to enter all this. And we're going to skip the part where it displays slope is undefined, because I want you guys to see what the students would see if they forgot to put in that part. So it's menu-driven coding. So every time we want to get a command from the 84, I can just simply press program. And you see along here, here are our submenus and our options for each of those submenus. And so if I arrow over to IO, you can see that that stands for input output. So I want to input, and so I'm going to press enter. And I want to input enter XY, so I'm going to go parentheses. And we see the quote, the quote is above your addition. And so we can press alpha and then the plus key. And then we want to press enter XY. And Curtis, is there a command for enter, or is that something that we have to type out?
No, you would need to type that out if you were wanting that, if you wanted to type in some sort of text there, because remember, a string here. So yeah, you might just say, and what I have used in the past for this particular program is in my input prompts here, what I do is I'll do X1 with a question mark instead. And that makes it a little bit shorter for students to type. They don't have to try to find, all the letters and that sort of thing. And I'll just, while you've got me, because, it's a little bit unmute and mute, whatever, but I love the fact that if I turn this loose to my students, I say, hey, you guys know the formula for slope. We've talked about it. We've introduced this idea of finding rate of change between 2 points on a line or on a graph. And just say, go forward and write a program that computes the slope between these 2 points. Most of our students, most of them, not all, but most of our students are going to come up with a program that prompts for the 2 points in this sort of format where we get those four values, and then they'll do y2 minus y1 over x2 minus x1 and display that, and they'll play with that for a little while. And then, Beth, you've already mentioned the conditional there, the slope is undefined piece, but it's fun to watch them go through this and play with it for a while. And yeah, it works, it's great. And it's all fun and games until somebody divides by 0, right? And then they get this, it doesn't work anymore, and we get this error, and oh no, what do we need to do? And I love to watch them with that problem-solving process of, oh, I need to know something new. And especially for my students that aren't CS, they don't know this stuff right offhand. It gives me a chance then to talk about what a conditional is and how that works and how we can use that to improve their program and help it to be a little more stable and be able to handle all the different types of inputs. So yeah, it's a cool way to introduce students.
Awesome. All right, so let's go ahead and do that shortcut that Curtis talked about. If we did want to write the word enter, keep in mind that we would have to do that alpha lock for that enter. And so we can just press alpha X. And then your question mark is to the left of enter. And so alpha question mark. Whoops, I forgot to put 1, but that's okay. I'm going to put question mark. So I forgot to put the 1. So if I want to go into insert mode, I'm going to hover over to where the block is on the question mark. And then I could simply press second insert and then type a 1 in there. And then I need to close my quote so that the 84 is saying, okay, I just want you to display this on the calculator screen. And then it knows that my input value, I need to know what my input value is going to be as far as my formula goes. And that syntax is your comma, which is above your 7, and then alpha A. And then we need to close the parentheses. And we would press enter. Now, we can see that we basically are typing similar lines for the next 3 lines. So it would be really, really nice if we had a copy and paste command. And so like Curtis said, you want your students to play, so you don't want to show them this the first time because you want them to come up with the fact, okay, is there not a shortcut to do this? Because we know our students, they want to take the easiest way they can. And so you want them to ask for this, is there a way that we could copy this? And if I put my cursor on that line and I press alpha graph, which is basically alpha F5. So if you've never worked with the function keys with the 84 platform, they do a lot of cool things, whether we're in programming or just in math type mode. And so that we have number 5 for copy line. So I can type number 5 and I can come right down to my cursor here. And then we would do alpha graph, and then number 6 is to paste the line. Now, notice that I really did not have to put an inner line there, but you have to be careful with this. So it's always better to have a blank line than not put a blank line in there, because every time you're doing, you're entering a new command, keep in mind the command has to start on a new line. And so those of you that are familiar with coding are very familiar with that, but that's going to be a common mistake that your students make at the beginning. And so if I press enter again, I can now go alpha graph and paste that line. And now I realize, okay, maybe I'll just take a shortcut from here and go alpha graph and paste line. If we want to go back and delete some of these, again, we have that cut line. And so we can just press 4. And I'll go ahead and do that now to get rid of those. So what do we need to go back and change? So keep in mind, this is pretty nice because we're in type over mode right now. So again, this needs to be Y1. And so alpha Y. And we're going to store this in B. Then we want to come back and change this to a 2. And this is going to be alpha C. So that's the variable that we're representing the second x coordinate. And then this will be Y2. And alpha D. So we said, okay, this is what we want our students to input. And we're going to press enter. And now what we want to do is we want to, again, we talked about the fact that we're going to skip that part right now. If A equals C, then display slope is undefined else. And we'll come back and talk about those commands in the end. So let's go ahead and put in our formula. So because we have basically stored those values of your coordinates and defined them as the variables A, B, C, and D, all we simply have to type in is alpha D minus alpha b. Close our parentheses, and this is great. You know, Curtis talked about that productive struggle. Maybe some students would forget to put that in parentheses as they would not really think about order of operations. So that could be another great way for some students to struggle. And then alpha c minus alpha a. And then we want to store that. So we're going to store the value of that slope. And the store command is to the left of your 1 key. And we want to store that as slope. So we want to store that as S. And I need to get rid of that double arrow. And then again, we're going to press enter. So we want to display that. And so if you think about the fact of both your input commands and your display commands involve the quotes. And so we don't want just a number there. Again, we want to say, what is this we're looking for? We're looking for our slope. All right. And so if we go to display, again, our commands are under the program key. And I'm going to go to input output. And again, we see that that's where that display is. And in quotes, whoops, which is above your addition sign. And I'm going to go ahead and put this in alpha lock now. We're going to type out slope. And then comma, which means we're just going to put the value. Whoops, I'm in alpha lock mode, so I've got to get out of that. And then that's going to be alpha S. So we're done with our program. Again, to go to the home screen, we're going to go second quit. And what I'd love to do in the chat box, if you guys can think about what points would y'all want to maybe try out. So we want to, maybe so part of what you could, if you want to guide your students, test something out that you think has a positive slope. Test something out that you think it has a negative slope and a zero slope and undefined stuff. And maybe have them come up with points where they think that those are the slopes that they're going to get. Because then they're using the paper and pencil. They're not just using a formula to plug it in. So Curtis, how about some points that we could start with? So I'm going to press program, and that's execute. So I'm going to execute slope 2 and press enter. Any ideas on a point, 2 points we could start with?
Oh, I don't know. Let's choose my favorite points. How about 2, 4, and
All right. We have a slope of 1. And so those are pretty easy. Think about the fact that your x, could maybe talk a little bit about why. That would be, something cool, is what difference, where do they see the differences are. So we have a slope of 1. How about a negative slope that's a fraction?
you asking me for that?
Sure. So,
A negative slope. Okay, so 1, 3, that's a fraction.
yes.
2, 2.
We get negative 1.
Oh, did I do the wrong? Oh, sorry, I meant 2. Well, that'll give me another
1, 3.
too much. Hold on, you're making me think on my feet here.
I know. How about
That gives you negative 2.
So why don't we make this last, we could do 2, 6. Or no, that's gonna, how about 2, 0? not really thinking well either. So we get -3. I guess our brains are just working on, working on nice numbers. But okay, so let's go with something that's undefined.
All good. All right. So how about 1, 3, and 1, 4?
Oops. So that would help if I ran the program again. So it may not, it's going to call up my last step. So now I have to go back to program and run slope A. And you said 1, 3, and 1, 4. So this is awesome. So it does give them an error. And I think it's real important just when your students get errors before. I always wish that we had go to as the first option, because they go, oh my gosh, I made a mistake, and they press 1 and they quit. But what's really, really nice is they really need to be choosing go to, but also look at what the explanation is. Your attempted calculation contains division by 0, and this fails. So then the question becomes, how could you adjust the program so that it gives you an undefined slope? And in this case, if we do press go to, what's really, really nice, at least it popped up that there was an error in the formula, and there it can't really specify why, but at least the students can say, oh, there must be something going on there. Any comments, or Curtis, do you want to add anything?
No, I just think this is really a cool opportunity to get students the idea of, oh my gosh, now I can troubleshoot my program, right? We've got a functioning program that works for lots of inputs, but not all of them. And so how do we handle the ones that are what we might call special cases, right? And so now we need to go back into our program and say, okay, wait, before we do the computation of y2 minus y1 over x2 minus x1, we need to find out if we're going to be dividing by 0 and see if we can't take care of that and say, hey, what does it mean when we divide by 0? And so, of course, we know, and the students have probably talked about that idea of undefined, and so now it gives us a way to use this conditional, this if-then statement. Then we can do that. So, yeah.
All right. So what I'd like to do now, just with looking at our times, I really would like to get into the next coding activity on the Inspire. Is let's look at how we would adjust this, because we're going to be doing some if statements in our next program as well. So I'm gonna press my program key. Let me get out of this, and I want to go over and just look at slope A, our first one, and talk about that a little bit. So I can just go over to edit and press enter. And oh wait, sorry, looking at the wrong one. Here we go. Slope 1, or slope. And you know what? I think I must have deleted it out of there. So we'll just go ahead and edit this. If you go in and look at this, what we have over here is, it's like Curtis said, what do we need to do here? So what is the problem? So the problem happens when we have the same value. X is basically the same value, right, for different values of y. And you can even have the students be plotting these on a graph to go with it, because that's what creates that vertical line. And so we talk about, that whereas the 2 points are rising, it's not running either way. It's not going to go to the right or go to the left, or if it's falling, it's not going to go to the right or to the left. And so that's going to produce what is an undefined slope. And so if you look over here, if we look at this program, basically it's saying if A is equal to C, then display that the slope is undefined. Otherwise, go ahead and work through the formula. And so when you're programming, that otherwise is basically if this else. And so again, this really teaches the students to say, okay, if this is the case, then go this way. If this is not the case, go that way. And it's almost that whole concept of what is like a miniature flow chart, so to speak, with this. All right, questions or comments so far? Okay, so I would like to go ahead and move to the next activity we have with programming on the Inspire. And I know we've got one or two younger or teachers that perhaps maybe teach in the elementary spectrum, and our Inspire is really, really nice for elementary or maybe some of the upper level elementaries. I've had third and fourth graders program with our Rover, but we can certainly look at this thought process. And it was amazing to see those little guys in action. And it's menu driven, and it thinks a little bit more like a computer, so to speak, than the 84 platform. So let's look at that next. So I'm going to get out of this, pop up my Inspire. All right, so what we want to do here is you know, when I was looking at this, I'm saying classifying triangles according to angle measure. We're really classifying triangles according to sides, and then we're going to classify them as being right angles, obtuse angles, or acute angles. So I could have phrased that definitely a little bit later, but let's talk about what we know about triangles. How do we determine whether it's a right triangle, an obtuse triangle, or acute triangle? And it really has to do, you know, it's that whole concept of the Pythagorean theorem. And, you know, that we know that if a squared plus b squared equals c squared, then we're dealing with the right triangle. A squared plus b squared is less than c squared, then we have an obtuse triangle. And if it's greater than c squared, then we have an acute triangle. But we also have something that we need to think about first. You know, what has to be the relationship between A, B, and C for it to even be a triangle? And so there's a lot of really cool activities that you could do with students before even thinking about coding. And think about, you know, in your elementary schools where you're really kind of learning some of this, you know, whether you use pieces of spaghetti or whatever you used, you had kids measure out different lengths of pieces of spaghetti or and try to have them construct triangles out of this, and maybe think about some things and discover relationships and what's going to happen there. And then perhaps how do we go through and how do we write a program with this? And so let's get started with looking at this. So a little bit about the Inspire. And I will say this is that the last 2 years I was in the classroom, I taught with the TI Inspire and the Navigator system, and I would never go back in a math classroom without it, just because of what it did to build student understanding and the connections that it allowed them to make. You know, what my pre-algebra students all the way up through my Algebra 2 students were able just to learn and understand was absolutely amazing. So if we press our home key, which is in the top right corner, basically you're looking at our home key, and you'll see that you have, I'm not going to worry about the scratch pad today, but we have, this is really documents. It's very much like what you may see on your computer: new, browse, current, settings. And so what we want to do is we want to open up a new document. Lots of ways to move around this home screen. We can use our arrows. We can use our tab. And those are the different types of pages that you can put on the Inspire: a calculator, a graphs, a geometry, lists and spreadsheets. So this functions truly like a spreadsheet does. It's dynamic. And I think that that's another area that our students don't really get enough experience with in high school is dealing with spreadsheets and formulas. So this is a nice feature of the Inspire. And a data statistics page to look at what they can do with statistics is just awesome on this. And we want a programming page, though, which we don't have the icon down there yet, but I'm going to go ahead and press 1 for new. And if you have your calculator and your it's asked for you to save something. I would say 90% of the time that we don't save anything. But the type of page we want, since we're going to write a program, is a program editor. So we're going to type number 9 or arrow down to that. And we want a new program. And we're just going to go ahead and title this Triangles. And then we press OK. So we can arrow down. We can, this is like a touchpad, so you can come up here and click OK. That's what a lot of the students are very comfortable doing. Or you could press Enter. Now, you know that you're on a programming page because you've got that little pinkish red outline there, and then you can see that here's the name that you've named your program. And what's nice about this is it's saying, okay, all of your codes, all of your commands are going to be between program and in program. All right. And so anyway, let's get started with this. I know I'm looking at the chat feature. I can definitely help you update that Inspire cast. So let's definitely send me an email at the end and we'll get going on that. All right, so let's look at what the program is going to look like. And so the first thing we want to do is some of these display, but you could have your students, type in. So we're talking about what kind of triangle we're looking at. We're going to enter the sides of the triangle. We do need something on there that says, let C equal the longest side. And these are a little bit different commands, so we tried to use a few different ones. And whereas the 84 looked at your input, on the Inspire, we're going to use demand requests. And I think Curtis mentioned this at the very beginning, that there's a lot of different ways to code with a lot of different commands that basically do the same thing. So again, this is menu driven, and I love the Inspire for that, because depending on what kind of page you are, you're going to have a different menu. And we have just a menu button right here. So we're going to press menu. And I forget where these commands are all the time. So I'm going to definitely, do that today. And it's in input output. So that would be the same concept as what we saw in the 84. And we're going to type 3 for request. And we need quotes. Now, what you'll notice on the Inspire is, let me find where my quote key is. You'll see your quote key above your multiplication symbol. And so if I go Control, that's your second function, and press your multiplication, it's actually going to put a box inside quotes. So you only have to open it, it's going to close it automatically. And I'm going to type in length of A, and you can abbreviate. And then I need to move outside my quotes and put comma A. And press Enter. Now again, it's the same concept as what we were working with the 84. We pretty much have a few lines that are very, very similar. So it would be really nice if we could copy and paste these. Well, guess what? On the Inspire, copying and pasting works exactly like it does on the computer. I can press and hold my Shift key down and arrow up and try to get up just that line. Sorry about that. Let me click right back here. So I'm right here. I'm going to press Shift and arrow up. It's grabbed that whole line. So on a computer, your keyboard shortcut would be what? Control C. So we can press Control C. We can come right down here and press Control V and Control V. Now all we have to do is go back and change the A's to B's and C's. And so you can arrow up here and go back, and then you have your delete key. So it's your backspace key. So again, very similar to the computer. I'm going to come over here and press B. Notice that when we're typing in A, B, and C outside the parentheses, that it's italicized. And what that's saying is, okay, hey, I recognize the fact that that's going to be a variable. So I recognize the fact already that that's what's going on. Then we'd have to say, if A plus B is less than or equal to C, then display that it's not a triangle. Now, the reason is here, we can't just use an if else, because we don't just have one if else. We have a couple, we have to go through this. We have to figure out if it's this, then it's okay. If not, let's go to the next. If not, let's go to the next. If not, let's go to the next. And so that's what's happening right here. And so we need to say if A plus B, and I always like to grab the commands versus typing in them, because there's sometimes, and Curtis is a lot better with this, there's sometimes when it's case sensitive and sometimes it's not. And so I think with coding, you've got to be very careful with that.
The thing about working on the Inspire software is we've taken away some of that, some of those tough issues, right? It was with the latest operating systems, we've taken care of the case sensitive syntax types of things. So typing them in the Inspire software or on the computer or on the handheld itself, when you compile the program, when you actually check the syntax and store, it will correct those pieces. So if I use all lowercase and then for some reason I needed to actually have capital I on an if or something like that, it actually corrects those things for me, which is really nice. But that's only a fairly recent, and I think it was in the last operating system or maybe the one prior to that. So most recent operating systems, definitely something to take care of. But I'm with you. I like using the menu-driven version of this because, one, it's a nice step, a small step from the block-based coding that students maybe got introduced to coding using, and it's not quite fully keyboard driven or typing out the commands in syntax completely. I have kind of the safety net, if you will, of using the tokens that come down from the menus to create my structure. For example, when you choose this if statement out of the control menu, when you go there and you choose that if, it's actually going to give you the ability to choose from several different constructions of that if statement. You can have an if then statement, you can have an if then else statement, and you can even input if then else, if else, if else, if else. So you can really kind of build a large statement there pretty quickly using the menus, which is nice.
Awesome. And so yeah, this is what Curtis is talking about, all your different options with the end and if. And so awesome. So if I look at what I'm going to work with now is, and refresh my memory, Curtis, which one am I going to look for here? We want to do the if then end if, correct? And then we can use the else then. So I think what I want is option 2. And then I can continue to do the else then. Is that correct? I think so. Okay. All right. So I'm going to press enter. And what I need to put, you can see right there, it's saying, okay, if you're going to do an if then, I need something in between there. And we're going to go A plus B. And less than or equal to, if you look above your equal sign, you have a great little template right there. that you can get all your equality and inequality symbols. And I want to look at less than C. And press enter. Then I'm going to go to the next line. Then we want to display. And so I'm going to go back and look for display. And let's say that I accidentally press control and I'm like, oh, I'm in this submenu. That's not where it is. Well, if you were on a computer, what do you press if you want to get out of something? You want to escape out of it. So press your escape key and you go right back. And so that's an input and output, display, and then not a triangle. So again, control plus, oh, whoops, I'm sorry, control divide for multiplication, and then put not a triangle. And I can actually press enter right here, even though I'm still inside the quotes, because it understands that I want to end this command line and go out to the next one. And so now, if that isn't the case, that's where we're going to use the else if. And so we can go menu, and that was under 4 for control. And then we need, let's see, else if, then, and then we can go a squared plus b squared equals c squared. Then display. Right triangle. And again, that's control multiplication. And then what can we do now? We need this. We need this a couple more times, correct? So if I hold my shift key, I can arrow up. And press, come down here, press enter, and just simply go Control V, Control V. And I could make it a little bit nicer as far as taking out spaces and whatnot, but I think that you know, we're okay just for leaving that right now. And then what we would need to be doing right here is just going back and typing acute. And then we would have to change that to greater than. And come back up here and type obtuse. Change this to less than. And you can see that I already have my end if program. Now I'm hoping that I haven't made any mistakes, but you know what? I'm actually okay if I have, because that's part of it. Agree? And how do we save this? So in order to run a program on the Inspire, it needs to be on a calculator page. So if I press menu and look at check syntax and store, you can see that you have 3 options here. You can check the syntax and store it, and then you would stay on the programming page. You could just check the syntax, or you could run it. And what run does is it checks it, it stores it, and it throws you onto a calculator page. So if you see to the right, you'll see that you have a keyboard shortcut, Control R. And there are lots of great, we've seen Control Z, we've see Control, you know, C. There's wonderful shortcuts on the Inspire, and that's another nice feature, is it really thinks more like a computer. So I'm going to escape to back out of this and use that keyboard shortcut and go Control R. And you can see that it's saying, okay, I'm thinking that you want to run this program. So it's already pasted that command on there. And so, yes, I do. So I want to press enter. And let's test this. So Curtis, why don't we throw in a triangle there that's actually, let's throw in 3 sides that don't form a triangle.
How about 1, 2, 3?
Right, not a triangle. So it looks like I have a little extra, well, maybe that was just asterisks in there. That's okay. All right. What about, as I press enter, again, it's going to call up what we did before. How about a triple? Or any triples or any links you want to try in the chat window?
Sorry. 3, 4, 5 wasn't it? Oh, 5, 12, 13. I like that one better. 5, 12, 13.
Okay, I can't see that. All right. Now, I love this. Like, think about this. This is really, really awesome for kids to discover a little bit about triples. I don't know that we do enough with these when they're doing testing.
How about 7, 24, 25?
Okay, and so then they can get, well, what happens when you double 3, 4, 5 or triple 3.5? So you can really get them to look, what was that?
7, 5, 24, 25.
Oh, that's a good one. Okay, so this is great. All right, and then how about, let's do an acute one. Gosh, really, we're now really thinking, right?
7, 24, 24.
All right. And so I think you guys get the drift of that. This is I love this. We started out with a nice, easy one, but when you really think about doing something like this with your students, and if we do it right in our classrooms and we really get the students to struggle and to think about it, then they can use this as a fun tool to check, to verify the results, and even little things like think about the Pythagorean, the quadratic formula. I know some teachers that let their students program that in there, but are they just programming it in there so that they can get the answer faster, or are they programming that so that they can really discover what's going on with the type of solution based on the values of A, B, and C, and the relationships and the signs, and what's really got to be true between A, B, and C for us to have, for us to not have any real solutions. So if we're doing it with those intentions, and I think we're doing it for the right way. And then they're going to understand the math first, and second, then it'll maybe help them when high stakes tests. So anything to add to that, Curtis?
Yeah, just a little bit to that, when you brought up, like, say, the quadratic formula, I love having students think about, in the same way that you built this program with the triangles, or the one that you built with the slopes, having students think about building a robust program that handles and gives me correct responses for all the different types of scenarios that I can do. I mean, certainly kids can start off and build that program right away, and they can get a response, and it'll work for many of the inputs that they could put in. But then it's the having it give me an error when I'm having a square root of a negative number, and I don't, what do I do? Oh my gosh, the discriminant is negative. How do I handle that? Or, it gives them an opportunity to go back and problem solve and really think through this. And I think, the way we started this with if you couldn't code it, then you know it. I think a student that understands where the program is broken definitely understands the mathematics that we've been trying to teach them. So I love this as another opportunity to introduce a different representation of coding, and then deal with it. And Laura, thank you. That's a great comment. Like, loving having them do this idea of come up with a discriminant and tell what it means, how many roots we've got, which types of roots are they, is it factorable? Yeah, that gives us that's a great way to do it. So you don't even have to have the whole quadratic formula in there. If they could just build and work with the discriminant, that's a great way to do it. So that's, yeah, totally. That's awesome.
Yeah, and then they understand, oh, okay, that really is the part that decides what kind of solutions we have and how many. That's awesome.
Right.
And you could even
Right.
think about doing when you get into doing like a cubic polynomial and putting in different values for A, B, C, and D, you know, as you're looking at disparities, line changes, it's like, why does that happen? I think that's awesome.
So one of the programs that I like doing is the traditional tables problem, right? Where we build, you have one table and 4 chairs around it, and then 2 tables and 6 chairs, and you kind of see that arithmetic sequence building, right? And we teach recursion and recursive sequences in Algebra 2, and getting students to recognize that the language that we use for building those recursive sequences is the same as if we were going to build a program with a for loop that counted the number of tables, and we built that entire same program. So I love those relationships. That's a really fun idea to kind of play with in code as well. So yeah, and definitely graph. Yeah, you could actually, Laura, you can get the program then to graph the solutions and plot those points.
Yes.
That would be a really fun program to play with as well. That would be a cool one.
That would be awesome. Be awesome. All right, so I'm going to show you guys a couple of resources and just a little bit about where you can get some information. So let me switch screens, and then we're going to end with a fun video that's one of my favorite from a couple years ago. So let me see if I can.
And while Beth is pulling that up, if you guys have any questions for either myself or Beth, please, you can put those in the chat, or Lynn is ready to get you guys up on the screen. You can ask those via your video and microphone if that would be preferable. So certainly we're ready at this time to start answering questions and things. So.
All right, can you all see the Texas Instruments site? I think I did that correctly.
I see the Texas Instruments homepage there on your screen share. Yeah.
All right, so real quick, we do have, that's the COVID-19 support. So if you guys want to know how we're supporting y'all with software moving forward, definitely go there. And under activities, if you go to, you can just go to TI codes, but I'm going to take you first to the innovator lessons, because that's where you can go from codes there. But we have a lot of different just STEM, computer science, math science. But if you go to 10 minutes of code here, you can see that this is where you can just do short little mini skill builders. This is great for students to do on their own because everybody can go at their own pace. A lot of teachers that are new to coding go here and click on whatever platform you code with. This is for just the calculators. This is where you get into the Innovator and Hub. And I'm going to click on the Inspire just to show you how this is broken up. And I'm just going to go to 10 minutes of code with just the handheld versus not with our other technology. And it's broken into units. And you can see Curtis mentioned loops. And if you click on a unit, each unit has 3 skill builders and then an application where they're doing a mini project. What I love about this is it basically says, this is what we're going to do, and this is why we're going to do it, and this is where we're going. And so it talks about, it doesn't just say, hey, do a loop. It talks about what is a loop used for and what are the structures of a loop. And as they go through, these are a little bit old. We now no longer have to have that split screen, but it will show you the commands as well. And so this is just awesome, and it's a great starting place. If you go back to that other page, and I know we're about out of time, you've also got a few other things as well, the math and motion activities with the rover. And one thing I do want to show you real quick before I show you that video, and I'll see if there's any questions, is our YouTube channel, and Curtis has done a lot of these, is absolutely amazing. What we are doing for teachers and for students, we have just put up, I don't know how many we've put up in the last couple months, but lessons that, you know, depending on what you guys are doing in the fall, you go to online learning a little bit, these are awesome. A lot of them for Inspire, a lot for 84. just know that this is here, and then Curtis and I can lead you in the right direction moving forward. I would like to show y'all a video that's about 1.5 minutes long. So, are there any questions we need to address at this point?
I haven't seen any come in yet. Lynn, will you know if somebody asks a question or needs to share? That'd be great.
All right. This is a video. I was in Gainesville, Florida a couple years ago, and the rover first came out. It was really the first opportunity that I had to work with students, and we were just really playing together. And I hope that you can see this and hear it. It's a great YouTube video. And this was 8th graders. And so they're programming the rover to draw these line segments. So hopefully you can hear what's going on here. So it's the good old angle of rotation. Their only knowledge was there were 180 degrees in a line and 180 degrees in a triangle. That was about it. So I think that shows you enough as far as what the rover is really doing for these students, where they're developing an understanding of an angle of rotation and what does it mean to, you know, what's a hard turn and things of that nature. But it was just simply awesome, this whole experience with that. Curtis, do you have anything to add?
I'm gonna just say no, I don't have anything to add on that.
All right, any comments or questions?
I haven't gotten any requests for folks to come on camera, but I think you all covered really, really well.
Awesome.
So
the link for that, do you have the link for that last video you shared?
I do. Let me pop it in the
and then we've gotten a couple of requests for the presentation link itself. And Lynn, you said you were going to add that to the resources. I emailed you the presentation during this here, so we should have that.
Yes, so what will happen is if participants completed the attendance form for this session, I can direct email it to them.
Okay, perfect. Okay. Awesome.
Mm-hmm.
And Stacy, if you have either Beth's or my emails, we also have those on the screen there. You can email us for other resources as well. So just let us know.
Yes, yeah, we're here to help. If you guys want to try any of this out, you know, we do have equipment and things of that nature. And I'm always happy to hop on a WebEx with you. And, you know, hopefully sooner than later, we'll be able to see each other in person. But thank you guys so much.
Well, I want to say thank you to both Curtis and Beth. You both did a fantastic job. Thank you so much for presenting during this summit. We really appreciate it. I want to say I'm a big fan of the TI 10 Minutes of Code. I'm a former math teacher as well, too, and just, you know, loved the Texas Instruments resources. And so it's just really, really great and grateful that you both were here to present. Thank you so much. And I think with that, your session is concluded.
All right, thank you all.
Thank you very much. Thanks for having us.
Everyone.
Bye-bye.
Bye-bye.
Bye-bye.